Okay, today let's take a look at homogeneous catalysis. So homogeneous catalysis is best represented by this very standard reaction here, which is the redox with iodide as well as peroxydisulfate. Now, if you look at the E0 values for these two reactions, okay, the oxidation of iodide, E0 ox is minus 0.54. Reduction of peroxydisulfate, the E0 reduction is plus 2.01. The E0 cell would then be a positive value, which means that it is spontaneous. It is therefore supposed to be able to happen on its own without any input of energy. Okay, so this will be a spontaneous reaction. It will be a feasible reaction. However, this reaction is found to be very slow. Okay, so even though it is spontaneous, it's not kinetically feasible. Okay, why? Because both the peroxydisulfate and the iodide are negatively charged. So therefore, they repel, which results in very high activation energy, very high EA. So therefore, the reaction will be slow. So therefore, we need to make use of homogeneous catalysis to catalyze this reaction. Now, homogeneous catalysis means this. Homo means that it's the same, okay, which means that the catalyst is in the same phase as my peroxydisulfate, which is aqueous, as well as the iodide, which is aqueous. Okay, so over here, we're using iron 2 plus as the catalyst. So how does it work is, it will separately react with your peroxydisulfate, okay, as well as the iodide separately. So first of all, iron 2 plus will undergo oxidation, and it will reduce the peroxydisulfate to your sulfate. Okay, the E0 cell for this is positive as well, which means it is spontaneous. And in this case, the reaction is fast because the charges are oppositely charged. Okay, the Fe2 plus is positively charged. The peroxydisulfate is negatively charged, so they are oppositely charged. So therefore, the EA will be low. Okay, it will be a fast reaction for this. Okay, so once your Fe2 plus brings the Fe2O8 2 minus over to form your sulfate, your Fe2 plus will be oxidized to Fe3 plus. So Fe3 plus will now be the catalyst that brings your iodide to the other side of the equation. Okay, so your Fe3 plus will get reduced back to Fe2 plus, so you regenerate your catalyst over here, is regenerated. Okay, and in this case, your iodide will be oxidized to your iodine. Okay, so end result is you achieve the same effect. Your peroxydisulfate becomes sulfate, your iodide becomes iodine. But instead of them reacting with each other, they now react through an intermediary, which is your iron 2 plus or iron 3 plus. So your iron 2 plus and iron 3 plus will bring them over one at a time. So you can imagine this like a boatman, bring them across the river one at a time to end up with the same product. Okay, so either Fe2 plus or Fe3 plus can behave as the catalyst. If Fe3 plus is used instead, the iodide will then be oxidized first instead of the reduction of your peroxydisulfate. So now let's take a look at a very quick animation to see this in progress. Let me just share screen. Okay, so over here you have a animation. So this is to illustrate what we have just explained. So the iron 2 plus will be oxidized to iron 3 plus, and in the meantime, the peroxydisulfate will be reduced to your sulfate. Let me just make sure that I shared it correctly. Okay. Okay, so if you watch this animation, so first of all, you have your peroxydisulfate and iodide on this side of the river. Your iron 2 plus will therefore first bring your peroxydisulfate over. Okay, and in the meantime, you can see that the electrons, there's a transfer of electrons from your Fe2 plus to your peroxydisulfate. Okay, there's a transfer of electrons from Fe2 plus to peroxydisulfate. And once it reaches over, your peroxydisulfate becomes a sulfate and your iron 2 plus becomes iron 3 plus. Now your iron 3 plus will go back and perform a redox with your iodide. You'll be reduced back to iron 2 plus. Okay, so this is how the reaction proceeds. Okay, so this is 1 minute of chemistry. I'll see you the next time.